Okay, that prior video was pretty long, so I think it's important that we summarize what we just talked about. So this video is just to provide a brief summary of everything in the prior video. So let's summarize what we call the critical value approach to hypothesis testing. Okay, so the first step, let's just recall. Step one was to create our hypotheses. So it could come in three different flavors. So one is a two-sided test where we're testing whether mu is different from some hypothesized value. Or we have two versions of a one-sided test. We could either say mu is bigger than some hypothesized value, or we could say mu is less than some hypothesized value. And just recall that HA, or the alternative hypothesis, is the research question. So it's the question of interest. It'll be asked in a problem, or if we're doing research ourselves, it'll be the question that we are asking. Okay, step two was just to calculate our test statistic. So pretty straightforward, our test statistic. And it's got our formula, T-stat, and it's equal to x bar minus mu naught divided by S over root n. And we recall that this is just the number of standard deviations x bar is away from mu naught. Step three was to create our rejection region. So we create rejection region. And recall that the rejection region just follows directly from the alternative hypothesis. So if it's a two-sided test, our alternative hypothesis is mu not equal to mu naught. And if that's the case, we divide alpha in half, and our rejection region is either t less than negative t n minus 1 alpha over 2, or if t is bigger than t n minus 1 alpha over 2, a positive value. Now, if we had a one-sided test, let's say our alternative hypothesis was mu less than some hypothesized value. Well, then, because this is less than, we will say the rejection region is t less than a negative value. And if our alternative hypothesis is mu greater than hypothesized mu naught, then the rejection region is T-stat greater than t n minus 1 alpha. So notice that if this is less than, then this is less than a negative. If this is greater than, then this is greater than a positive. If this is a two-sided test, we use alpha over 2. And if this is a one-sided test, so either this or this, then we do not use alpha over 2. We just use alpha. And these critical values, so this is, by critical value, I mean these values. Critical values come from our t-tables, which are the values that are from the tables that we used in the prior chapter to create confidence intervals. Step 4, conclusion. Okay, so if t-stat is in our rejection region, so let's take an example. Let's say we are operating in this case. So if t-stat is in the rejection region, what does that mean? That means t-stat is less than negative t n minus 1 alpha. So if we were testing mu less than mu naught and our calculated t was less than negative t n minus 1, then we would reject the null hypothesis and accept the alternative. Okay, let's take another example. Let's say we were doing mu bigger than mu naught. Okay, so then we would reject if our t-stat, so if t-stat is in the rejection region. What does that mean? That means our test statistic t-stat is greater than positive t n minus 1 alpha. And if that was the case, we would reject the null hypothesis and accept H naught. Now, of course, if t-stat is not in the rejection region, then we fail to reject H naught. What does that mean? So if t-stat is not in the rejection region, well, then that means t-stat is not greater than Tn minus 1. So in that case, so t-stat not in RR, that would imply that t-stat is less than or equal to Tn minus 1 alpha. So if this is true, we reject the null hypothesis. If this is true, then we fail to reject the null hypothesis. Again, that's for this case right here. Okay. And then finally, our step 5 is just our interpretation. And all we're doing is we're going to take our conclusion and restate it within the context of the problem. So hopefully that made it seem a little less daunting. I think this page right here is probably a better handy sheet. So once we start going through some example problems, I think this summary page will be a little more helpful to keep us organized as we work through some problems.